Hey everyone, so if you're an architect or developer in the Kubernetes world, you know that security is everything. But what happens when your clusters are spread out across AWS, Azure, and GCP? Yeah, things can get messy, and they get messy fast. Today, we're going to build a really simple but powerful blueprint to get unified security, and it won't matter one bit where your clusters live.
Does this look familiar? I bet it does. You're trying to lock down your apps, but AWS security groups have their own way of doing things, Azure network security groups have theirs, and then GCP firewall rules are a whole different ballgame. You end up with these disconnected policies, you've got potential security holes, and honestly, it's just a massive operational headache.
It's definitely chaotic. But you know what? It doesn't have to be. We're going to cut right through all that complexity and build a single, consistent security architecture that just works everywhere.
So, here's the game plan. First, we'll unpack why this multi-cloud puzzle is so tricky. Then, I'll introduce our secret weapon, Kubernetes NetworkPolicies. After that, we'll get our hands dirty and apply this blueprint to 3 super common scenarios. We'll see how tools like Calico and Istio fit in, and finally, we'll see the real power of having one policy that truly rules them all.
So really, why is this so hard? Well, it boils down to this. Every cloud provider gives you their own native tools, and they're great, but they're not portable. A security policy you meticulously craft for AWS is completely useless in Azure. This just forces your teams to become experts in 3 different systems, it slows everything down, and it makes it almost impossible to prove you have the same security posture everywhere.
The real solution here is to stop thinking about the cloud provider's specifics and move up the stack right into Kubernetes itself. The foundation, our blueprint for consistent security, is a native Kubernetes network policy. This is the absolute key.
Now, the official definition is pretty straightforward. A network policy is just a spec that says how groups of pods can talk to each other and to other things on the network. Think of it as the ultimate source of truth for your traffic rules inside the cluster. And because it's a standard Kubernetes object, it works the exact same way on AWS, GCP, or even in your own data center.
To make that a little more real, here are a few ways to think about it. It's kind of like a firewall, but for your individual pods. It's the official rulebook for all your in-cluster traffic. Or, and this is my favorite analogy, it's like a bouncer for your app. It's got a list, and it's checking who gets in and who gets turned away at the door.
All right, enough theory. Let's see how this blueprint actually works in the real world. We're going to take it and apply it to 3 essential security patterns that, let's be honest, you're going to find in pretty much any application you build.
Okay, first up, the classic web-to-database connection. We need to make absolutely sure that only our web front-end pods can talk to our database pods. Nothing else gets access, period. It's the principle of least privilege in action, right?
The flow is dead simple. You've got your web pod over here, and we're going to define a rule that says traffic from this pod is explicitly allowed to talk to our database pod over there. Any other pod that tries to hit that database? Nope. That traffic gets dropped on the floor.
Now this is where it gets really cool. Check out how we can do this with 2 totally different but super popular tools, Calico for the network layer and Istio for the service mesh. But look at the logic. Calico says, select the database pod and allow traffic from the web pod. Istio says, select the database pod and allow traffic from the web service account. It's the exact same intent, just expressed using a slightly different type of identity. It's amazing.
Okay, on to scenario 2. Imagine you have a critical internal API. Maybe it handles billing or user data. This thing should only be reachable by other specific services inside your cluster, and never, ever from the outside world.
So the goal here is to create a kind of secure bubble. We might say, okay, app A can talk to our internal API, but our default stance is to block everything else, especially any sneaky traffic trying to get in from outside the cluster. We want a default deny posture. And you won't believe how simple this is. To create that default deny lockdown, we just select our internal API pod, and then we define an empty ingress rule. That's it. By applying a policy that has no allow rules, you're basically telling the system, deny everything. And look, Calico and Istio do it in almost the exact same way. All right, for our last scenario, let's flip this whole thing around. Instead of controlling what comes into a pod, we're going to control what goes out. This is so critical for preventing data exfiltration or stopping your pods from calling out to malicious websites. So let's say you have a worker pod that needs to call a specific trusted API on the internet, like a payment processor.
What we want to do is create a rule that opens up one tiny specific door for egress traffic to only that API's address, and then slams every other door to the internet shut.
Now here, you'll notice the syntax starts to look a little different. Calico works at the network layer, so it lets you whitelist a specific IP address range. Istio works at the application layer, so it uses something called a service entry to allow an external hostname. But again, take a step back and look at the architecture. The core concept is identical. Define a very specific allowed exit point and deny everything else.
So, we've just seen 3 different scenarios, implemented in 2 different tools, and all of this leads us to the real aha moment of this entire strategy. Here's the most important point. Even though Calico is working down at the network layer, with IPs and ports, and Istio is working way up at the application layer with service accounts and host names, they are both built on the exact same fundamental idea: defining security policy based on workload identity, not on some fragile temporary IP address.
And when you finally embrace this identity-based approach using Kubernetes native policies, man, you unlock some incredible benefits. This is where all that architectural thinking starts to pay off big time. The ultimate goal, the value proposition, is the simple, powerful idea: define once, enforce everywhere. You write your security intent one time in a completely cloud-agnostic way, and you can sleep at night knowing it will be enforced consistently whether that app is running in AWS, Azure, GCP, or anywhere else.
And what you get is one single, coherent security architecture. It's written as code, it's portable, and it lives right next to your application code in Git. This is what security as code really looks like in a multi-cloud world.
So I'll leave you with this one question to think about. Is your security policy something you design and build as a core feature of your platform? Or is it an afterthought, something you try to bolt on later for each cloud you deploy to? Because by adopting a unified blueprint like this, you're making security a first-class citizen of your architecture.